All right, I am Drew here at Republic Amps. And when I first started building amps, I noticed that some amplifiers that had a pair of 6L6 tubes were listed at 20 watts, and some amplifiers with two 6L6 power tubes were listed at 50 watts. So, how do you get 20 watts out of a pair of big bottle 6L6 tubes? So that's kind of what this video is about, is how manufacturers rate their amplifiers. And it comes down to the manufacturer's data sheet. So here I have two data sheets for a 6L6 GC. So these data sheets are created by the manufacturer. They they make the tube, and then they hook this tube up to a machine called a curve tracer. And they apply 400 volts in this case to the tube, and it creates these curves, and it spits out voltages and currents. And then over here they did the same thing, and they applied only 250 volts, and it spits out a completely different set of curves. And the curves are based upon this EC2. EC2 is the screen grid, which is one of the elements that's inside the tube here, the screen grid. The screen grid kind of dictates how the tube is going to operate. And obviously you can see from the curves here that if you apply different voltages to the screen grid, it's going to behave differently. So I have a lot of stuff drawn on here. I drew a bunch of these lines in here. These lines don't come on the curve sheets. The curve sheets just look like this. They're just empty sheets. So I drew these straight lines on here. These lines are the load lines, and this basically tells you how the tube is going to operate based upon how much voltage you're going to feed the tube and the impedance of the transformer that's going to be connected to the tube. So these things are really, really important when you're designing an amp. And as a guitar player, you probably don't think too terribly much about what kind of transformers are in your amplifier, or what the impedance ratio of the transformers is, or how much voltage the amplifier is running inside. You just take it for granted that it's going to work, and that's fine. But I'm going to tell you kind of how it works if you want to sit through a little bit of this stuff. It's kind of interesting. So in my amplifiers, I run about 420 volts in mine. Most of these big bottle tubes can handle up to 500 or 600 volts, sometimes more. But here, voltage times current, voltage across the bottom, current up the side here, voltage times current equals power in wattage. So when you draw a load line, you take your voltage that's in your amplifier. Mine's 420 volts. So I start with 420 volts, and I draw a line up to my transformer impedance. And without getting too technical, your tube is going to see 1/4 of your transformer impedance. So I use a 4K transformer. So the tube is going to see 1,000 ohms, 1K. So if I do 420 volts divided by my 1,000 ohms, it's going to give me 420, or 0.42 amps, which is 420 milliamps. So you can see I drew my line straight from 420 volts straight to 420 milliamps. And it just so happens that this goes right through the knee. That's what they call this curve, this bent area. This is called the knee of the curve. And the knee of the curve is where the amplifier produces maximum amount of power. And I'll try to explain that to you here, because I remember I said wattage, your power in wattage, is plate voltage times your current. Voltage times current equals power. So this is our bias point. So we're going to start here, because the voltage, that's the total voltage swing, is from your bias point down to where this load line crosses this zero line. So it crosses right around, we'll call it 75 volts. So you have to subtract that 75 volts off there, because it's not going past that. So if we have 360, we'll call it 360 volts, minus our 75 volts that we don't get to use at the bottom there. It's 285 volts. So this is going to swing 285 volts. And we're going to multiply that 285 volts times our maximum current, which is also where this line crosses, which is about, we'll call it 300, and we'll call it 330. So we multiply that times our 330 milliamps equals 94 watts. So the formula for finding power in an amplifier is voltage times current divided by 2. So we have to divide this by 2. Oh, crap. I hit it too many times. So we had 95 divided by 2. So we get 47.5 volts. We get almost 50 watts. 50 watts out of two 6L6s at 420 volts. That seems pretty reasonable, right? So, you know, the manufacturers usually with a pair of 6L6s or a pair of EL34s usually comes in right around 50 watts. They call it a 50 watt amp. So if we move over here to the 250 volt chart, you'll notice that it doesn't swing nearly as much voltage and it doesn't have nearly as much current. So same deal here. So we got our bias point here is about 220 minus another 75. Whoops. So you have 220 volts minus our 75 volts. So we have a total voltage swing of about 145 volts. And a total current where it crosses here at about 170. So we got 145 volts times 170 milliamps divided by 2 again. So we're only getting 12 watts, you know, out of a pair of same tube, 6L6s, big bottle 6L6. If you run it down to 250 volts, you only get 12 watts out of a pair of these. So you can really tame an amplifier by designing it with only 250 volts. So if we want to keep going with this, let's take a look at a 6V6. So I ship my amp with either a 6V6 in it or a 6L6 GC. So if I put these in it and bias them up, I can get 60 watts. If I put these in it, I can get 30 watts. So it just depends on how much power you want to make. And you can take this guy out, put this one in, rebias it, and go back to 60 watts. You could take this out, rebias it, and go right back to 30 watts. You know, it's a pretty neat deal. And this is how. A 6V6 data sheet here, they only come with 250 volt curves. They just, I guess they assumed that nobody was going to run them higher than 250 volts. So we have to take some of this data off the data sheet and kind of interpret it a little bit. So if we cruise, where are we? I have another different data sheet for a 6V6 here that has a little bit more information on it. So what I'm looking for here is, this is where my 0 volt line is going to be based upon my screen voltage. So at 100 volts, my 0 volt line will be right here. If I put 150 volts on the screen, my 0 volt line is going to be here, 200 and 250. So my 250 volt screen grid 0 line right here is right around 100 milliamps. If I go over here to the this other standard data sheet here, the plate curve's drawn at 250 volts. You can see that my 0 line is right here at 100. So all that's telling me is that these lines are more or less evenly spaced 50 volts apart. So I have 100 volts, 150 volts, 200 volts, 250 volts. It appears that I can keep drawing these lines more or less evenly spaced apart in 50 volt intervals if I want to keep going up with my screen voltage. So I run mine at 420 volts. So I have to use this information and I go into Paint and I add more lines. So I put in these green lines that are spaced more or less evenly apart. So I have a 300 volt line now, a 350 volt line, a 400 volt line. And now I can draw my load line so I can see how much power I'm going to make roughly. And this is a pretty close estimate, you know. But you can see I'm still down here using 420 volts. And my load line is going to cross the zero line right somewhere around here. So I drew this orange line straight down here, and that's going to show my total voltage swing, which it looks like it's about 300 volts or so. Looks like it's going to swing about 300 volts where it crosses the zero line up here. But the important thing is here is because I'm running higher screen voltage, I'm going to get a whole lot more current out of here. Normally I would have gotten 100, but now at 400 volts, I'm double that at 200. So same thing, voltage times current equals power. We'll bring our calculator up here. I'm at a voltage swing, a total voltage swing of about, looks like 300 volts. So I'm swinging 300 volts times a full at least 200 milliamps, so we'll call it 200. Divided by 2 means, look, I got a 30 watt amp now. So I'm running 30 watts out of a pair of 6 V6s, you know? It's a pretty neat deal. So this is how most amps that run 6 V6s usually run them around 300 volts, and they usually get about 20 watts, 18 to 20 watts a pair. I get 30 out of it because I'm running them at 420 volts. So that's kind of how I do it over here. So, you know, if you see some of my videos where I'm running my amplifier with 6 V6s in it, you know, and it sounds really good, it's at, you know, 30 watts, and then sometimes it's really loud, and it's because I got an amp loaded with 6 L6s in it. And if you really want to go nuts, you can load up these giant ass 6550s in it, and at 420 volts, these do almost 80, 85 watts for a pair of these things, man. It's super cool, man. This thing really moves some shit around, you know. So that's it. I hope you learned something, and I'm going to try to do more tech tips, you know, about how amplifiers work and things you can do with tubes, you know, noise issues, and maybe even some amp comparisons and stuff in the future, man. So if you have questions or want to know more about this, or you have specific questions or anything, man, you could shoot me a message over on my website at republicamplifiers.com, or you can hit me up on Facebook and message me there, or if I turn this into a YouTube video, you can just leave comments on the YouTube video. That'd be great, man. But until then, I'll catch y'all later.